All right, so we're going to start talking about something called limits at infinity. And if you notice here in all of these problems on page 17 in your notes, and you should be taking notes, you can see that all of these limits are as x approaches infinity. Now, what we've done in the previous lesson is we've just plugged whatever x was approaching in for x into the expression, which is a little bit more difficult to do when you have infinity. Now, I know Mrs. Engel does it one way. I'm not sure how Mrs. Henrich did it if you had her, so I'm just going to show you my way. I like it. If you don't like it and you remember their way, feel free to use it. So what I do is I do something called end behavior. So I take the highest power in the numerator and the denominator and I circle them. So I'm like, all right, well, the highest power in the numerator and the denominator is x over x. If that reduces to a number, that's our answer. So the answer is 1, because x over x is 1. Now, that won't always be the case. I'll show you what happens when we get there then. So let's look at number 2. Highest power in the top, highest power in the bottom. I'm going to circle those, and I can see that the x squareds would cancel out, right? And then that reduces to 3 over 4. So again, that's a number. We're good. All right, now let's look at number 3. This is where it gets a little bit different because that doesn't reduce to a number. Okay, we really have, if we look at that, we have 3 in the numerator, and then I would have 2x squared in the denominator, right? Okay, so this is what I like to do. You remember with your summer assignment, there were graphs that I told you that you really should memorize. Well, this, granted, I understand this isn't one of the graphs you had to memorize. However, this is going to behave like 1 over x squared. These numbers here, the 3 and the 2, they don't really matter that much for what we're doing anyway. We're just looking at the fact that there's an x squared in the denominator. So if I remember what the picture of x squared looks like, which I should, I usually just draw a sketch, and then I ask myself, real simple, this thing is x approaches infinity, right? So as I go toward infinity, going toward infinity is going to the right. So I'm going to look at this part of the graph and look at what happens. As I go toward infinity, do you see that that graph goes lower and lower? So what it does is it approaches, doesn't touch it, but it approaches a y value of 0. So then my answer here is 0. All right, let's look at number 4. Same thing, highest power on the top and the bottom. That does not simplify to a number. That actually just simplifies to 4 over x. And again, summer assignment, those 10 graphs you had to memorize, that's going to mimic 1 over x. That numerator of 4 really doesn't matter significantly in what the picture looks like. So I remember that 1 over x is in the first quadrant and the third quadrant. And then I do exactly like what I did in number 3. So this is as x approaches infinity, which means that we would be moving to the right. And if I look at that, that would be this part of the graph. And look at what happens as I go toward an x value of infinity. My y value is getting lower and lower, just like it did here in number 3. So then the answer is going to be the same as number 3, which would be equals 0. All right, next one, number 5. Well, this is very nice for us because those x's cancel out, and my answer is just 7 over 4. Number 6, highest power in the top and the bottom. Now, that gives me 9/5, but with an x in the numerator, so 9x over 5. Okay, so with this one, this is kind of like y equals x. All this is going to do is just change the slope of the line, but the behavior of the graph, which is really all I'm looking for, is going to be the same. So we know that y equals x passes through the origin and it's a diagonal line, right? Again, the only difference is the slope of this line might be a little bit steeper or less steep, but it doesn't matter because this is what I'm looking for. I'm just looking for the behavior of the graph because watch. This says as x approaches infinity, so as x approaches infinity means go toward the right. I'm going in this direction. And look at what happens. As I go toward infinity, my y value keeps getting higher and higher and higher. It doesn't really matter how steep this is. Even if my line, let's just say, it had a steepness that looked more like this, the behavior is still the same, right? The behavior still is, as I get further to the right here, my y value is still going up. So if my y value is still going up, we say that that y value is infinity. Okay, does that make sense? All right, now let's look at number 7. So I'm going to do the same thing here. I'm going to circle that. That's 1/4 with an x in the numerator, right? That's an x to the 5th. Whoops. So that is 1/4. Let me turn that into a 4. And the x in the top. Well, guys, this 1/4 x is really like 9/5 x. It's still the same picture. The 1/4 just applies to the steepness. Okay, so still the same picture, just maybe steeper or less steep. Still, as I'm going toward infinity, I'm still approaching a y value of infinity. So then my answer here is infinity. That doesn't look like one, but there we go. All right, now I put this one on here. I like this one because you've got to take the square root of that 9x to the 4th. So if I take the square root of 9x to the 4th, that's going to be a 3x squared, right, over a 4x cubed, which is really 3 over 4x. I'm so sorry that I am running out of room here, but I'm going to try to squeeze it in anyway. Okay, so this 3 over 4x, follow this up, is really like this 4 over x. Again, these terms here don't matter. The behavior of where the x is what does. So 3 over 4x is going to be like 4 over x, which would be this graph. And look at what happens as we go toward infinity. Our y value gets lower. So number 8, your answer is going to be 0. I am going to squeeze it right down here at the bottom. I'm sorry for the messiness of it all. Okay, number 9. Let's do the same thing. Circle the highest power, top and bottom. Ooh, that's so nice, right? Those x's cancel right out. And there's your answer, 1/3. Okay, so now let's look at number 10. Highest power in the top and the bottom. Man, we lucked out twice. I'm going to just write that answer underneath. So that's going to be 7 over 2. Done. All right, now number 11. We've got x squared in the numerator, x cubed in the denominator. That reduces to 1 over x. Okay, that's not a constant. Let me sketch that picture. There it is. And this says as x goes to infinity. So if x goes to infinity, my y value goes to 0. All right. Okay, so my answer here is 0. All right, 12, 7x squared, and negative x. So when I reduce that, I'm just going to write that down here. That gives me negative 7x. Okay, well, that's kind of like positive x, except just sloping in the opposite direction. Remember that 7 doesn't matter. That just is going to increase or decrease the steepness of the line. But just be careful, because this is a negative slope, we have to make sure we go down. Now this says as x goes to infinity, what happens to the y values? Well, as we go to the right, which means x goes to infinity, what's happening to our y value? Do you see that it's getting lower and lower? So our answer wouldn't be infinity, our answer would be negative infinity, because we're getting lower and lower each time. Okay, last one, number 13. So I'm going to circle the highest power in the top and the bottom. Just remember that that's underneath the square root. Now, just be careful. This is really the square root of x cubed. Oops, that should be a 3. And then the square root of 4x squared, which we know is 2x. Now let's talk about this. Remember that that really is x squared times x, right? And then I know that the square root of an x squared, those two terms are going to cancel one another out, the square and the square root. So that's going to bring that x on the outside, and then I still have this x right here underneath the radical. So that's x radical x. And then that is over 2x. Okay? And if I simplify that, those guys disappear. So really what I have is 1/2 radical x. Now again, that 1/2 doesn't matter. The behavior of the graph is what we're looking for. So again, from the summer assignment, a radical graph looks like this. And then I'm going to go back and I'm going to look, and it says it's going towards infinity. Now, by the way, sometimes it'll go towards negative infinity. In this case, it doesn't, so we're just sticking with positive infinity. And look at what happens. If I start here and I go toward x equals infinity, in other words, going to the right, I'm going to the right, what's happening to my y values? Do you see my y values are going up and up and up? So then my answer to this question would be a positive infinity, right? Because it's going up.